Right, here's another little problem which has come my way, which I'll share with you. And it says if ax plus by equals 1 and cx squared plus dy squared equals 1, if that pair of equations has but a single root, show that a squared over c plus b squared over d equals 1, and then further that x is a over c and y is b over d. Now, I've written a little note on the side which will come in handy. It says if x squared plus px plus q has only one root, then p squared equals 4q. That's where the theory of equations comes in. So q equals p squared divided by 4. And the equation then becomes x squared plus px plus p squared over 4 is 0, which is a perfect square, from which we easily see that x will equal minus p over 2. So let's return to the main problem. And first of all, from the first equation, we'll get that y equals 1 minus a times x over b, and we substitute that into the second equation, which will then give us cx squared plus d bracket 1 minus ax all squared over b squared equals 1. And when you simplify all that and tidy it up, it should come down quite easily to the following, that b squared c x squared, let me rewrite that, that'll be b squared c plus a squared d x squared minus 2a dx plus d minus b squared is 0. Just give me a second to check that that is all right. Yes, yes, and yes. Okay, so for single roots, we know that the discriminant of that has to be 0, so we'll get 4 a squared d squared equals 4 b squared c squared plus a squared d times d minus b squared. 4's conveniently cancel out, and we'll simplify that now. The left-hand side is a squared d squared, and on the right-hand side, multiplying all that out, we get b squared cd minus b to the 4th c plus a squared d squared minus a squared b squared and d. Here, those two terms conveniently cancel each other out, and what we are left with then on the next line is 0 equals b squared into cd minus b squared c minus a squared d, from which we can remove the b squared. That means the term in the square brackets is 0. So 0 equals cd minus b squared c plus a squared d. And divided by cd, divided by c times d, will give us 0 equals 1 minus b squared over d minus a squared over c, which leads to the result that we require, a squared over c plus b squared over d equals 1. Right, now to move on to the second part. We have an equation here in x, and that's over here. And by what we saw before, we saw that then x would have to equal half, the negative half of 2AD, so that would be AD over B squared C plus A squared D. And B squared C plus A squared D we can see from over here. I think that should be a negative, okay? B squared C plus A squared D will equal CD. So that's AD over CD, which is A over C, which answers that little part. Sorry for the mistake earlier on. And now Y equals 1 minus AX all over B, and substituting for the x, that gives us 1 minus A squared over C all over B. A squared C, we can see, is just 1 minus B squared D from here. So that comes to 1 minus B squared over D all over B, which comes to B squared D over B, which is B over D. And that completes the question. Thank you for listening, and sorry for the earlier error.